Hello everyone, I am Ma Zhenglu from Sichuan Vocational College of Chemical Technology. Today, we will study the mechanical properties of polymers. The so-called mechanical properties refer to the relationship between the force applied to an object and its deformation. The applications of various polymer materials, such as plastics, rubber, and fibers that we learned about earlier, mainly depend on their mechanical properties. As a material, it is required to maintain a certain shape and should hardly deform under a certain load or force. Why should we study the mechanical properties of polymers? When evaluating the practical value of polymer materials, to make full use of their strengths and avoid weaknesses, we must control their strength and failure patterns, and thereby purposefully improve their material properties. It is necessary to understand both the macroscopic laws and the microscopic mechanisms of the changes in the mechanical strength of polymer materials. This chapter introduces the physical quantities and variation laws that describe the macroscopic mechanical strength of polymer materials. And from the perspective of molecular structure, it discusses the factors affecting the mechanical strength of polymer materials. This will provide theoretical guidance for the development of materials with better performance. First, we need to understand the common mechanical concepts in materials. For example, what is external force? What is internal force? External force usually refers to the force applied to the material, which causes the material to deform. It is generally referred to as a load. For example, tensile force and compressive force. Common items we see in daily life, such as spring grips or rubber bands, apply an external force to cause deformation. The force we apply is called external force. Correspondingly, internal force refers to the force exerted by the material to resist external force and maintain its original state. After the external force is removed, internal force causes the object to return to its original state and gradually dissipates. This can be seen in the recovery force of springs or vulcanized rubber. In addition to this, there is a special case. When the deformation of the material is maintained at a certain level, the internal and external forces reach equilibrium, where their magnitudes are equal and their directions are opposite. As shown in the diagram, external force P and internal force F are equal in magnitude and opposite in direction. In addition to understanding external and internal forces, we also need to understand the definitions of stress and strain. Stress generally refers to the internal force per unit area in the material. It is usually represented by sigma. In equilibrium, its magnitude equals the external force per unit area. Strain refers to the change in the material's geometric shape and dimensions under the action of external force. It is usually characterized by the change in unit length, area, volume. This is generally represented by gamma or epsilon. Depending on the way the external force acts, the resulting deformation varies accordingly. The basic forms are tension, compression, and shear. Next, we will use some diagrams to help students understand more intuitively. This is a simple tensile test system for common materials. By applying an external force longitudinally, the material deforms longitudinally. When the material undergoes stretching, there are usually two corresponding values. One is the tensile strain, also known as the relative elongation. The other is the tensile stress. The calculation of tensile strain is relatively simple. It is the length of the material after stretching minus the original length, and then divided by the original length, which gives the relative elongation. On the diagram, this is represented as the original length L0, and the length after stretching is L. L minus L0 represents delta L. and dividing by the original length, L0, gives the tensile strain. Tensile stress is the applied force F during stretching, divided by the initial cross-sectional area of the material. Specifically, this is F divided by A0, which gives the tensile stress. As shown in the diagram, this is a simple case of shear, commonly seen in daily life. Shearing usually causes the material to deform, creating an inclination angle. The inclination angle in the diagram is theta. The tangent of the inclination angle represents shear strain. In addition to shear strain, we also need to understand shear stress. The corresponding shear stress is the force F during shearing, divided by the initial cross-sectional area of the material. This gives the shear stress. Apart from tension and shear, the third basic form is simple compression. Compression is commonly observed in gases and fluids. Compression strain is calculated by subtracting the compressed volume from the original volume, then dividing by the original volume. This gives the compression strain. After learning the basic forms, we also need to learn the commonly used mechanical strength, also referred to as mechanical strength properties. Mechanical strength is one of the important indicators of the mechanical properties of materials. When the external force on a material exceeds its bearing capacity, the material fails. Mechanical strength measures the material's ability to resist failure caused by an external force. It refers to the maximum stress a material can withstand under certain conditions. The common unit used is megapascals. The last concept is Poisson's ratio. In a tensile experiment, the ratio of the lateral decrease in width to the longitudinal increase in length is called Poisson's ratio, usually represented by epsilon. In the diagram, this is shown as delta M divided by M0 divided by delta L divided by L0, which gives the material's Poisson's ratio. The negative sign indicates that the directions of the lateral and longitudinal strains are opposite. For most rubbers, the Poisson's ratio of the material is typically 0.5. For crystals and glasses, Poisson's ratio usually ranges from 1/4 to 1/2. In this course, we mainly covered the overview of the mechanics of materials. We learned what external force is, what internal force is, and also studied stress and strain. We covered the basic forms of deformation, tension, compression, and shear. Lastly, we learned about material mechanical strength and Poisson's ratio, and mastered their calculation methods. That concludes the content of this lesson. Thank you for listening. See you in the next class.